Okay guys, welcome back. Today we are covering relational mappings. So far we have only covered a single table in SQL, but now we need to have relational data. So we're going to have multiple tables and data mapping to each other. So the example we're going to use is a customer and an address. There are three types of relational mappings: a one-to-one, a one-to-many, and a many-to-many. So a one-to-one relational mapping in our context of a customer and an address, you would have one customer and each customer has exactly one address. A one-to-many relationship, you would have one customer and multiple addresses. And a many-to-many relationship, you would have many customers to many addresses. So an example of this one would be perhaps you have two people, a mother and daughter, living in one house, and they're two separate customers, but they both map to the same address. Meanwhile, there's a friend of the family who also has their address in their record keeping. So addresses are coming in and out of many customers. And you may have noticed that I did not cover a many-to-one relationship. Well, this is actually the same as a one-to-many relationship. It's just the inverse. So whatever you would do for a one-to-many, you would just do the opposite for a many-to-one. So this is what our table is going to look like. They're going to be very simple. So we have a customer table and an address table. One thing we haven't really covered yet is what a primary key is. So looking at the customer table, we have customer ID of 1 and 2 for John and Jane. Well, each row in a table needs to be uniquely identifiable, and that's what the primary key on the left-hand side is. Let's say someone had the same name of John Doe and you had two entries with the exact same values. How would you be able to tell them apart? Well, you would tell them apart via the primary key, or in this case, the customer ID. If we look at the address table, it also needs a primary key. So the primary key in this case would be the address ID, and the values here are 101 and 102, for example. But how do we map these two tables together? Well, you do that with a foreign key. So if we look at the customer table, on the right-hand side, we have address ID. Now, this is not unique for each row. You could have multiple rows that have the same address ID. But what this does is it then points to the address table and says, okay, in the customer table, it's a foreign key. In the address table, it's a primary key. So it links the two tables together. And this is how it's going to look with our one-to-one mapping. Now, eventually, we're going to come back and we're going to change this relationship from one-to-one to one-to-many, and then we'll change it to many-to-many. And we'll have to do a couple of things in order to be able to achieve that. Okay, so we have a lot of work to do. First, we need to create our tables for customer and address. Then we need to create our entity classes in Java for customer and address. Then we need to annotate our entity classes to define the relationship and the cascade type, which we will cover once we get there. And then lastly, we need to expose a customer endpoint and test it out. Okay, make your way over to MySQL Workbench and run this query. This will be available in the description. So we're going to use NoBS, that's our database. Then we're going to create table customer. We're going to have an ID that is a big integer, and this is going to be our primary key. Now that we've talked about this, you should know what this is, and it is going to auto increment, which means it starts at 1. We're going to have a column first name, a column last name. VARCHAR is another name for string in SQL with a length of 255. It's going to have an address ID, big int, and we add the foreign key constraint. So we're telling it, okay, this is a foreign key that's going to map to address and address's ID. We then need to create our table address. So create table address, ID, big int, again, primary key and auto increment, a couple of strings, street, city, and state. So go ahead and run this. And we actually got an error. And I did this on purpose to make sure you see this. So failed to open the reference table address. What's happening is it's trying to create this table customer and referencing this address table, but the address table hasn't been created yet. So what we have to do is make sure you run this in order. Now if we run it, it works. So we used the database, we created the table address, and we created the table customer. Okay, let's make our way over to Java. Okay, coming back to our project, first I want to create a new folder. So File, New, Package, and I'm going to call it Customer. In the Customer folder, File, New, Java class, named Customer. I'm also going to create an address. New Java class address. I'm also going to put it in the customer folder. Perhaps this is not the best practice, but this is what we're doing today. So going back to customer, let's fully complete this. We annotate it with entity. This tells it that this is supposed to map to a table in our database. Our table name was customer. And we are going to use Java Lombok, so we don't have to generate our getters and setters. We have private integer ID, private string first name, private string last name, and we have a private address called address. So ID is going to be annotated with @ID, telling it that this is the primary key. It is going to have a generated value with a strategy generation type of identity. And we're going to specify the column name. Column name is equal to ID. For first name, we need to specify the column name. Column name is equal to first underscore name. At column name is equal to last underscore name. And here's where we annotate our relational mapping. So we're going to say at 1 to 1. And we're going to specify a cascade equal to CascadeType.ALL. We're going to come back to this and discuss exactly what this is doing. And then we need to join column name equals address ID. So what this does is says, okay, the column address ID, that is what you need to take and go look up what your address is going to be in the other table. And I just realized I used underscores. Our string names should be camel case. So let me fix that. Underscore is the database name. Okay, moving over to address. We're going to do the same thing. So at entity, because this maps to a table in SQL, we're going to say our table name is address. And we are going to use Java Lombok to generate our getters and setters. And we have 3 fields: private integer ID, private string street, private string city, and private string state. 4 fields actually. And finishing out our annotations, so ID needs to be annotated with @ID, saying that this is the primary key. @generated value with a strategy generation type identity, and the column name is equal to ID. For our street, we just need the column name. Name is equal to street. City, our column name, is equal to city, and state column name is equal to state. And that should do it with our annotations. Now notice on the customer entity, we have the one-to-one mapping and how to join the column. But if you notice, on the address entity, we do not. So this means that the customer owns the relationship. Now we could come back to address, add a customer field, and have it map bidirectionally. But for our use case, we're going to keep it unidirectional, meaning the relationship only exists from the customer to the address. We're not going to go backwards from address back to customer. There might be good use cases when you would want to do that, but not in this example. Okay, next up we need a controller. So new, Java class, customer controller. If we come back to our product controller, if we remember, we annotated it with @REST-controller and a request mapping. So let's copy this. This will be a REST controller, and we're going to say the endpoint is customer. Let's add a get mapping. We're going to say /ID because we want to get a certain customer by ID. Public response entity. We're going to return a customer in that response entity. Get customer by ID. It's going to have a path variable of integer ID. And remember, this ID needs to match this ID exactly so that we can get it from the endpoint URL. Okay, the next thing we need is a repository. So new, Java class. Remember, this is an interface. So we're going to say customer repository. We need to annotate it with @repository. It is going to extend JPA repository. And remember, we have these angle brackets. So let's go back to our product repository, and we have product and integer. This is our unique identifier, and this is the entity. So let's copy this over. But of course, this is not going to be a product. This is going to be a customer. Coming back to our controller, we need to inject this into our controller. @AutoWire private customer repository. And this is going to return a response entity .ok. We will call the customer repository .find by ID, pass in the ID. And remember, this returns an optional accounting for what if we can't find it. So the simplest thing to do is just get. Okay, so now we have our endpoint set up. Just a friendly reminder, this is not the best way to do this. What we would want to do is we would want to take this logic, abstract it out into its own service class so we can do more complex computations on it. For example, what if we can't find the customer? What if we can't find the address? Or if we wanted to add other logic. And the other thing is, you don't want to expose an ID like this because anyone could come along and just type in the user's ID and then have access to the customer. So this is not the best way to do this. I'm just trying to demonstrate the quickest thing we can do to explain relational mappings. Okay, so at this point, we need to go to our database and add some data. Now, making our way back over to my SQL workbench, I'm going to delete these create table queries. And this is where I challenge you to go ahead and generate the queries yourself. You want to insert data into your address table and into your customer table. But here's the answers. We're going to insert into address, street, city, and state values of 123 Main Street, Cityville, California. And then we're going to insert into customer, first name, last name, address ID of values, John Doe with a value of 1. We're still using No BS database. Let's go ahead and run this. And we have a green check mark, which means it was successful. Let's go ahead. I'm going to comment these out. So command / I'm going to do a select star from address. And there we are. ID of 123 Main Street, Cityville, California. So that worked. Let's do the same thing for customer. And there he is, John Doe with an ID of 1 and an address ID of 1. Now remember, this address ID of 1 matches to the 1 in the address table. So now we are ready to go to Postman and test this endpoint. Back to my project, I'm going to click Run. So making our way over to Postman, if you notice we have a collection that has to do with products. I want to make a new collection because this is about customers. So new collection, blank collection. I'm going to name it customer. I'm going to add a request. It is a GET request. And it's going to be localhost 8080/customer/1. And we're going to call it get customer by ID. Let's go ahead and run this. And there we have it. John Doe with our address. Now this is a very important point. Notice Java Spring Boot automatically gave us the correct JSON structure. So nested within our customer object is an address object with its own squirrely braces. And then it lays out ID, street, city, and state. So it automatically did this for us, which is super useful and incredibly helpful. Okay, so earlier we talked about cascading. So coming back to our customer entity on our one-to-one mapping, we defined a cascade type of all. And what this means is if we update a customer that also has an address attached, it will also update the address. So even though we're on the customer repository, because these are linked up with a one-to-one mapping, it will also update the address. So let's do this in a very quick and simple way. Coming back to our customer controller, we're going to do a post mapping, public, response entity, update customer. We're going to take in a request body with a customer named customer. We're going to do a customer repository.save, which also includes our update function if you remember correctly. And then we shall return a response entity.ok.build. Let's rerun our application and go into Postman. So in Postman, let's rerun our get customer by ID, and we are still getting it. So I'm going to copy this JSON. I'm going to duplicate this request. This is going to be a post request, and it will just be at the customer endpoint. Go into our body, raw, JSON. I'm going to paste that JSON in here, and I'm going to change California to Texas. So when I send this, this should update the database. I get a 200 status. Let's go ahead and get that same customer by ID. And it changed to Texas. So this is really important, right? We were on the customer repository. We were handling a customer, but because we also sent an address with it, whatever address we sent also got updated. So this is a cascade. One table influences data in another. So this is CascadeType.ALL. Okay, great work, guys. In the next video, we will change this to be a one-to-many mapping. So one customer can have many addresses.